Alright, so in this video I'd like to talk about the detection of NEOCP object 2018 VS6, Victor Sierra 6. So a friend of mine came to me and said, hey, I tried using Tycho to detect this object, but for some reason it wasn't able to do so, so could you take a look? So he sent me his data set, and so that's what I'd like to do in this video is share my findings. So to start off with, we'll load up Tycho and import the data. So these are 9-second exposures, and there's actually 150 of them. So that's quite a lot of data to be able to look through, which is a good thing. They've already been aligned and plate solved, so we can go ahead and start off with the synthetic tracker. So start with, in this process, you want to specify a star subtraction threshold. So this is, in other words, known as a static threshold. The point of this is to exclude pixels that do not contribute any meaningful information and that would otherwise basically result in more false detections than you would care for. So what value do you use? Well, basically, you go as low as possible. I mean, this is obviously too low because now you're excluding pixels that you'd actually want to use. But I keep raising it up until I no longer see grainy fuzziness is the scientific term. So in other words, I don't want this snow or whatever in the image. So we're at 79, and I would say this is about right here. So again, that's probably a bit too low. So I would say this is 81. So it's really, and I can verify. I can look at the rest of the image. I don't have any more of that graininess going on. So there's really no question in my mind that a threshold value 80, 81, maybe 82. So I'm saying 81 should be used for this data set. So I click OK, and the next question then is, what do we choose for the sensitivity threshold? That's and that is in fact what caused him not to detect the object, was that he had chosen a sensitivity threshold of 22. Now you might ask, well, okay, so what is the proper setting here? Well, that's a good question. So I come from a background of working in radar systems, and the answer really is you want a threshold that is low enough that you actually do have some false detections. In other words, if you're not seeing any false detections, as we call them false alarms, then you're not sensitive enough. So when he told me he used a threshold of 22, I ran that, and it comes back with 0 detections. In other words, no false alarms or anything at all. So I knew right then that we're not sensitive enough with a setting of 22. So again, this is going to depend on your data set. If you only have like 11 images, or some very few number of images, then you probably can't use too low of a value. But we have 150 images that we're looking at here. So the way that works is the more images you have, the more data the program has, the more sensitive it can be. And that's just, again, signal to noise ratio goes up as you have more and more images to work with. So we can actually choose, in this case, what I thought was, let's just cut that down to the sensitivity threshold of 10. So let's see what happens. So I click OK, and we can choose adaptive for our image sets, meaning the program will try out different motion vectors. I've added a wizard. So this last part here, so after you've chosen static threshold and the sensitivity threshold, now you tell the program what kind of motion vectors to try out. So we're almost done, but we just need to fill in these values. So I have a wizard here. It tells you basically some ideas of what it thinks would be good values. So you can always adjust these, but if you don't know what values to choose, you can ask the wizard. And so an exposure time of 9 seconds, you can choose start value of 2. So I've done that. A delta time of 21 seconds between images, then you can choose a start value of 42. So I've just chosen what the wizard said to do. So I click OK. So I'm just going to say, hey, let the wizard try it out for me. Now, if I don't limit the speed in PA, in other words, if I wanted to do a purely blind detection, meaning if I did not know the speed or the position angle of the asteroid, then there would be over 500,000 motion vectors, which is quite a lot. And that's just simply the nature of this particular data set, is that it's a fast-moving object, and there's actually a pretty high delta time, relatively speaking, between images for that. And certainly the step size of 0.05. You know, if we were to do 0.15, then that would cut it down. You know, but anyhow, I'm just going to do what the wizard said to do. So again, that's over 500,000. But since we do know this is a NEOCP object, so we do know roughly what the speed and PA ought to be. So I'm going to go ahead and limit the motion vectors down to according to somewhat of the known motion of the object. So that narrows it down quite a bit. So I can go ahead and click OK. And this is a new feature I'm working on. Cluster computing will be supported by Tycho, but for now I'm just going to use my local machine. So I click begin, and yeah, it's going to take, I've already done this before, so it's going to take about a minute, but I'm not going to have you have to watch a progress bar for a whole minute, so I'll resume in just a moment. Okay, so that took 55 seconds to go through the data. And as you can see, it detected exactly one object, or one track. And so the question is that our NEOCP object? Well, it has a calculated speed of 10.67 arcseconds per pixel and a calculated position angle of 235.5. So I'm pretty confident that is our object, and we can actually look at it in the image viewer. And so again, we can also stack these images according to its motion, and you can see it's that's a very faint object for this particular it's a very faint object for this instrument, but nevertheless it was detected. So that was the key, was I had to use a sensitivity threshold of 10, not 22, and you can see even using 10 we only had one detection. So I would say even 10 is maybe too high, but I mean it did detect it. So the question might be, well, could we have chosen a lower sensitivity threshold? So let's go ahead and see. What would have happened if I had chosen, again, there's no question what that should be. So what would have happened if I had chosen a sensitivity threshold of 5? Okay, so that's very, for most of the data sets I've worked with, I do generally tend to have the threshold set at like 35 even. But since we have so many images, we can choose a lower threshold. So I will choose 5, and again, all these will be the same, so I'm not going to change anything else. And if we run the, I'm just moving these windows so you can see them in the video. So let's see what that looks like. So I'll resume the video here in a bit. Okay, so this time it took 62 seconds rather than 55 seconds. Okay, so so yes, we do have, using a sensitivity threshold of 5 rather than 10, we do have now 63 detections rather than just 1. But that's to be expected, and that's actually a good thing. Now the question is, did it rank our asteroid, our NEOCP object, as number 1? And yes, it did. So track number 1 is our object that we were looking for. So even though I chose a very, very low sensitivity threshold, it still detected the NEOCP object as track number 1. And so that's very good performance in my opinion. And again, you can, there's 150 of these images, so that's the object right there. And yeah, so those are my findings. Indeed, it did detect it just fine. The key point was the sensitivity threshold. So, all right, well, thanks for watching.